So you people have also studied these things in the PSCC subject, but today we will discuss how to calculate the address if we are given the address of the first element of the array. So it is very easy in the case of one-dimensional array, but in the two-dimensional array there will be two types of representation in the memory, that is a row measure order and column measure order, means in which order we are taking input of the array, row by row, that is row measure, and column by column, that is column order, column measure. So two-dimensional array is nothing but it is a grid or table form. So this, it can be declared like this: data type, an array name, then number of rows and number of column, or we can say these are the two dimension. It is the first dimension, it is the second dimension. So number of elements in this dimension, the number of elements in this dimension. So the first number, or we can say the range of this particular dimension. So the first number in bracket is the number of rows, and second number in bracket is the number of column. As normally we treat it like when we are making some programs on the matrices. In that case, it is the number of rows and this is number of column. So the upper left corner of any grid would be element 0, 0. So it is this like when we are dealing with the array, then the starting index of the array will be 0. So the same will be for two-dimensional array. In this case also the dimension of the first element of the array will be 0, 0. Like if we are having an array like this, it is a 2 cross 2 array. Suppose the array name is m1 and it is like this: m122 means 2 row and 2 column. Okay, so it will be m100. It will be like these are the number of column, these are the number of rows. m100, m1, sorry, तो m1 की जगह m कर देते हैं. So it will be m00, then m01, m10 and m11, like this. So this is the first element. Now we are having two representations in memory, that is first one is the row measure and second one is the column measure. We will see those in the later slide. So normally we simply use the row measure order form, means we initially take input of the row 1, then row 2, then row 3, so on. Mean then row 1, row by row and from left to right. And let's suppose we are using the column measure order form, then we will take input of column 1 from top to down, then column 2 from top to down, then column 3 from top to down. That will be the column measure order form. Okay, so this is a declaration like we are having an array ARR. It is the name, it is the type, these are the dimensions value, number of row and number of column. So it is like this: 0, 1, 2, 3. It is a 3 cross 3 matrix or table. Array 0, 0, it will be array 0, 1, array 0, 2, like this. So when we will deal with row measure order, then we will enter in this order, and when we will deal with the column measure order, then we will enter like this, column by column. And if we are talking about the initialization of the two-dimensional arrays, then we can do it like this. At the without the user's intervention, we can directly assign the value. So it is array 2 cross 3 means 2 row and 3 columns. So these values will be inserted at their appropriate places. All the index values will be automatically initialized by these values in this particular list. Means it is the first value that will be for 0, 0, for 0, 1. So it is distinguishing like 2 rows here and 3 columns here. Now initialization of the two-dimensional array, this was the first slide. Then now we can do it like this. Suppose we are writing it like this in table 2, 3. Then it will be treated like first 3 elements in the first row and second 3 element will be in the second row. And what it will do, initializes the elements of the first row to 0 and the second row to 1. It is according to these values. Okay, so the initialization is always done by row. So the above statement can be equivalently written as like this. We can separately specify the rows using the brackets. This is the first row, second row like this. Or we can do so in the matrix form as we have done in the previous slide. This is the matrix form. Okay, this is the first row, this is the second row. And if it is not explicitly specified, then it will take automatically all the elements row by row. So when the array is completely initialized with all values, then it need not to necessarily specify the first dimension. But it is only for this case, means the first dimension can be missing and this is the second dimension. So it will be automatically taken all the variables into the first dimension. The first dimension will be initialized automatically, like there will be 2 rows in this declaration. If the values are missing and an initializer, then they are set to 0. Let's suppose we are assigning the values like this and some of the values are missing. So you can see here are 2 rows and 3 columns. So in each row there will be 3 elements, 1 1, and it is missing here 2 comma 2 elements are missing. So those elements will be automatically initialized to 0. Okay, so this will initialize the first 2 elements of the first row to 1 and the first element of second row to 2 and all other element to 0. Okay, and if we want to set all the elements of a particular array to 0, to in spite of or in place of writing a loop for that purpose, we can do so by writing a loop. And suppose this is an array table 3 cross 3, and for this we can write a loop for I equals 0, I less than equal to, or I plus plus, and here for j equals 0 or j less than equal to or j plus plus, and here I can simply do table and I j equals 0. So what it will do, it will initialize all the elements of this array to 0 one by traversing each and every location. But if we do not want to do like this, then we can simply do like this in table 3 3 and row 1 entries, row 2 entries, row 3 entries. These all will be initialized to 0. So these are the methods for initializing the 2-dimensional array. Now this can be the traversal of the 2-dimensional array, like we are assigning here values to this 2-dimensional array by this initialization, and here we are accessing the elements of each at each location of that particular array. What we are doing, we are simply printing the values. So this loop will we are as there are 2 rows, so outer loop will be executed for 2 times 0 and 1, and the inner loop will be executed for 3 times 0 1 2. Yes, there are 3 columns in this. And what is this? It will just place the elements in the next row. Every time when we are printing each row, then each row will be printed in the next line like this. So first it will be printed like this, 20, 30, and then 40, 50, and 60. So it is for that. So it is basically for formatting purpose, how we are printing them. And here you can see the space here. So it is for the space in between the elements, each and every element. So it is the traversal. So basically each data structure, we are having 3 type of operation: insertion operation, deletion operation, and traversal operation. And there is one more operation, that is the update operation. Means if there is an entry already inserted in the data structure, then we can simply update the value by a new value. That is the updation operation. But basically there are 3 operations can be possible on every data structure: insertion, deletion, and traversal. So insertion means inserting a value at any location, and deletion means deleting an already inserted value, and traversal means accessing each location of the array one by one, or accessing all the entries in that array one by one. Okay, so this is the traversal operation. So in the array, suppose we are having one dimensional array, then we can access elements from 0th index to the last index. And in the same case, if this is a two-dimensional array, then if we are accessing each and every enter in every row, or we are accessing all the elements or the table, then that is the traversal operation. So this is basically it is not difficult in the case of array, as you people have already studied these concepts. But if we are talking about the stack and queue and linked list and tree and graph, then that is not the easy operation, except in the case of a stack and queue and the linked list. If we are traversing the graph, then we are having different traversal methodologies, like in which order we want to traverse the tree. And same for the graph. In the tree, we are having three traversal approaches: in order, pre-order, post-order. And in the case of graph, we are having two traversal approaches, that is breadth first search and depth first search. But in the case of array, as these are linear data structures, linked list, stack, queue, so there is no issue in the traversing these arrays. We can start from one end and we can go up to the last end by accessing each and every element. So now let's come to the implementation of two-dimensional array in the memory, how we can do the implementation in memory. So a two-dimensional array can be implemented in a programming language in two ways: row measure implementation or column measure implementation. So I have told you in the previous slide, like row measure implementation is nothing but we are dealing the array and row by row, means we are taking input in the array row by row. Okay, so suppose like I can simply give you an example. Suppose these are the entries. So it will be a tabular form. चलो जो नेक्स्ट स्लाइड आएगी तब इसको देख लेंगे, अभी थोड़ा सा कंफ्यूजन होगा. तो रो मेजर ऑर्डर में जो भी आप एंट्री दोगे, दैट विल बी द फर्स्ट रो, देन सेकंड रो, देन थर्ड रो. एंड इन द कॉलम मेजर फॉर्म में हम जो भी एंट्री इनपुट देंगे, दैट विल बी द फर्स्ट कॉलम, देन सेकंड कॉलम, देन थर्ड कॉलम. So I will show you a diagram, these things, that how these entries will look like and what is the basic difference in between them. Because if we are dealing in the row measure implementation, then address of a particular element will be calculated in different way as compared to the element which is stored in the column measure implementation, because the same element's position will be differ in both the approaches. Okay, so this is the row measure implementation order. So row measure implementation is a linearization technique in which elements of array are read from the keyboard row wise. That means the complete first row is stored, then the complete second row stored, and so on. Like this is the array. Then this is the first row: A00, A01, A02. Then next row A10, 11, 12. So this is it is changing first row. You can see here, not this is, and this is the third row. Row 1, row 2, row 3. So the storage can be clearly understood by arranging the array and the matrix form. Like it is the simplest thing. We have already used the two-dimensional array in this order: A00, 01, 02, 10, 11, 12, 202, 122. So for accessing these elements, we can simply run a loop, outer loop for I 0, I less than equal to, or I plus plus, and inner loop. So it is for row, and inner loop j equal 0, j less than equal to, or j plus plus. So it will be for number of column. So for each row, let's suppose it is 0th row, 0, 1, 2. So this is for the column: 0th column, first column, second column. Okay, so I equal 0, I less than equal to I plus plus, j equal 0, j less than equal to j plus plus. So for when I equal 0, then it will execute for j equal 0, 1, 2, means 0, 0, 1, 2. this element, this element, this element. When I equal 1, it will execute for this element, this element, this element, inner loop. And when I equal 2, it will execute for A20, 21, 22. So it will access and store the element in row by row order, in the row major order form. Now the address of the elements in row major implementation, because in the case of array, as the arrays are stored in the contiguous memory location, so there is no need to keep track, there is no need to keep track of the address of each and every element. Let's suppose we are having an array of 1000 by 1000. Then if there is a need to store the address of each and every element, then that will be a very difficult task. So as the array elements are in contiguous memory location, then we can simply keep track of the address of the first element, and we can calculate by the address of the first element address of rest of the element. Okay, so the computer does not keep track of all elements of the array, rather it keep a base address. It is the address of the first element. This is the base address B, and it calculates the address of required elements whenever it is needed or required. Okay, so it calculates by the following relation. It is for the row major implementation. Address of ij, it is denoting the number row number, it is denoting the column number. This is the base address. This is the data type. Let's suppose the array is an integer array, then in that case it will be 2 bytes. According to the system by system it will change. So now it is n I minus L1, it is j, it is second one is plus j minus L2. Now what are these things? B is the base address, W is the size of each element array, n is the number of columns. Okay, if we are dealing with the row major order, then it will be the number of column, and when we will deal with the column major order, then we will use the number of row, but not here, in other place. So B is the base address, W is the size of each array element, n is the number of columns, and how we can calculate the number of columns? That is U2 minus L2 plus 1. I will show you separately that what is the meaning of this. Here L1 the lower bound of row, L2 is the lower bound of column, U1 is the upper bound of row, and U2 is the upper bound of the column. Why it is required? So basically normally we simply denote it like this, but we didn't show the do not show the range. So we are showing like this 2 2 means number of elements or number of row, but it may be possible the array declaration can be like this, L1 comma it will be U1 and L2 comma U2. It is the lower bound, it is the upper bound, it is the lower bound, it is the upper bound. Okay, so it can be given like this, a of 0 and 2, and it can be, it is not necessary it will be 0 to 2, it can be anything. Suppose it is 3 to 6. So if we want to find out the number of row and number of column, then the formula is same, 2 minus upper bound minus lower bound plus 1, upper bound minus lower bound plus 1, 2 minus 0 plus 1. So here we will have 3 elements, 0 to 2 and 0, 1, 2, and the same way here 6 minus 3 plus 1, that is 4. 4 how? 3, 4, 5, 6. Okay, so it will be an array of 3 row and 4 column, or 3 equals 4 table or matrix. तो यहाँ पे क्या होगा, हमको ऑलरेडी जैसे हम नॉर्मली यूज में लेते हैं, इट इज गिवन ऑलरेडी गिवन द नंबर ऑफ रो एंड नंबर ऑफ कॉलम. अब जैसे ये वाला अरे था like this, we can denote it like a first dimension, second dimension. तब देखो it is 0 1 2, it is 0 1 2, so it will be 0 2 and it also 0 to 2. ठीक है, so it is the lower bound, it is L1, it is the upper bound u1 means lower bound of the row, upper bound of the row. It is L2 lower bound of the column and upper bound of the column. It is upper bound of the column. If we want to find out the number of element in this, then number of row equal u1 minus L1 plus 1, that is 2 minus 0 plus 1, that is 3. So total number of row कितना है 3. And in the same way number of columns equal u2 minus L2 plus 1, that is 2 minus 0 plus 1, it is also 3. So 3 rows and 3 columns with total 9 elements, 3 into 3. Or the length, we can say number of element in the array will be m cross n, means number of row multiplied by number of column. So the number of element in the first dimension multiplied by number of element in the second dimension. Okay, so it is like this. So address of aij equal base address plus size of each element or the data type, that is, and multiply by number of, ये bracket है यहाँ पे. In the bracket it is starting with number of columns, then I minus L1 means I minus lower bound of the row plus j minus L2, j minus lower bound of column. तो इसमें हम किसको सब्ट्रैक्ट कर रहे हैं, लोअर बाउंड को सब्ट्रैक्ट कर रहे हैं. मल्टीप्लाई किससे कर रहे हैं, वी आर मल्टीप्लाइंग इट विद द नंबर ऑफ कॉलम इन द केस ऑफ रो मेजर ऑर्डर. So it will help you to remember this particular formula. A of ij equal b plus w into n minus n multiply I minus L1 plus j minus L2, and this n is multiplied by this first dimension I minus L1. So let's take some examples so that it will be clear to all that how we are given a question, then how we can calculate the address of the element in that particular array. So a two-dimensional array, it is defined like this: a of 4 to 7, or it is minus 1 to 3. So what is this? It is basically first dimension, it is the second dimension. Okay, here the lower bound of this row is 4 to 7 and 4, and upper bound is 7. So its range is 4 to 7, and the range of the second dimension is minus 1 to 3. Okay, so this is the array. अभी हम देखते हैं one by one. It requires 2 bytes of the storage space for each element. So 2 bytes is the value of 2 is the value of w. Okay, if the array is stored in row measure order form or row measure form, then calculate the address of the element at location A62, and we are given the base address as this. So what we are given the base address b, it is 100. We are given the L1 4, L2 minus 1, U1 7, U2 3, and W, that is 2. Okay, so we need to find out the address of the element at the location A62. A62. It is the value of I, it is the value of j. Okay, so before now what was the formula? The formula, it was the formula aij equal b plus w and I minus L1 plus j minus L2. So I'm simply writing it here. It is, sorry, यहाँ लिखा हुआ है. It is the address of aij equal base address plus w n into I minus L1 plus j minus L2. So you need to put the values which are given in this. Base address 100, w it is 2, number of column n, it will be u2 minus L2 plus 1, that is 3, minus 1 plus 1, that is 5. So 5 multiply 6 minus 4 plus j minus L2, that is j is 2 minus it is L2. L2 is lower bound of second dimension or the lower bound of column. So 2 minus 1. Okay, so we will get it 100 plus 26, that is 126. So it is very simple. Other question given, you are given the question in this form, you are given the dimension like this. Okay, or it can be written like this and separately a bracket like this: a 4 to 7 and second dimension minus 1 to 3. Okay, so this was the row major order form. Now the column major order implementation. So in column major implementation, memory allocation is done column by column. That means first the element of the complete first column is stored, then the element of the complete second column is stored, and so on. Like if we are having this array, तो मैं यहाँ पे ये array का ड्रॉ कर देता हूँ इसमें, इधर नहीं, suppose I want to draw here. हमारे पास एक array है, we are having a array of 3 cross 3 size. Okay, it is 0 1 2, it is 0 1 2. So this will be a 0 0, a 0 1, a 0 2, a 1 0, a 1 1, a 1 2, a 2 0, a 2 1, a 2 2. Okay, so the row major order देखो ये sequence था, first three elements ये थे 0 0 0 1 0 2, but in the column major order first three element will be this, a 0 0, a 1 0, a 2 0, 0 0 1 0 2 0. This is the column 1. Okay, a 0 1 1 1 2 1, 0 1 1 1 2 1. This is the second column, and 0 2 1 2 2 2. This is the third column. This one. So we are just taking input of the elements in this order, column by column, column 1, column 2, column 3. तो अब इसमें क्या है, जैसे हम रो मेजर ऑर्डर में एलिमेंट्स इनपुट ले रहे थे, तो it was at the we can say fourth number. Now it is here at the second number. So we want to find out the address of the element, then it will be changed. So the formula will be changed accordingly. The storage will be like this: 0 0 0 1 0 2, 1 0 1 1 1 2, 2 0 2 1 2 2. But element will be taken input column by column. Sorry, row column by column. First column, second column, third column. So address of the elements in the column major order form will be like address of aij element will be base address plus data size. Then now it is the number of row m. और देखो ये क्या है, यहाँ मल्टीप्लाई नहीं हो रहा है, इट इज लाइक दिस i माइनस l1 प्लस m j माइनस l2, ये इस तरह से है जो प्रीवियस फॉर्मूला में था, ठीक है, बट ये इसको यहाँ स्टार्टिंग में यहाँ पे राइट लिख दिया है. सो इट विल बी मल्टीप्लाइड विथ दिस m multiplied by j minus l2 plus I minus l1, and we know the meaning of these. M, it is a single difference in this. It is the value of m. M is the number of row. So we can find out the number of row means upper bound of that row minus lower bound of that row plus 1. So it is basically number of elements in that particular row. Now we can use this formula. Suppose we are given this, a two-dimensional array defined as this, minus 20 to 20 and 10, 35. It requires 1 bytes of storage space for each element. So if the array is stored in column major order or column major form, then calculate the address of element at location A030. Okay, and we are given the base address as 50. तो यहाँ क्या क्या गिवन है हमको, we are given as L1 equal minus 20 and U1 equal 20 and L2 equal 10 and U2 equal 35. Okay, and we are given the base address equal 500 and storage it is 1 byte, and we are given the size W equal 1. So we can put these values here. We need to find out the number of rows. So number of rows will be L1 minus U1 plus 1. That is, sorry, not L1, U1 minus L1 plus 1. U1 minus L1 plus 1 means upper bound minus lower bound plus 1. So basically start कहाँ से हो रहा है? It is starting from minus 20. It is not starting from 0. Okay, so एक तो हो गया -20 to -1 दैट इज 20, और एक हो गया 1 to 20 दैट इज 20, 20 + 20 40, और एक हो गया 0. ओके, और वी कैन कैलकुलेट बाय दिस. So 20 minus -20 plus 1, that will be 41. So these are the number of rows here, and we will use this number of rows in the formula. Okay, so base address 500, L1 -20, L2 10, U1 20, U2 35, and W is the size 1 byte. Okay, so I equal the ये क्या था इसका मैं फाइंड आउट करना, हाँ it is the value of I एलिमेंट्स को फाइंड आउट करना, it is 0 and J equal 30. ठीक है, so I equal 0, J equal 30, and a number of row, so it will be 41. So address of aij or a030 will be, it is 500, it is 1, 41, j30 minus l1, that is 30 minus l2, that is 10, plus 0 minus l1. Okay, it is 0, I minus l1, or minus -20, and after solving we are getting this address. So this is the address of that element in that particular dimension, in this particular array.